This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a molecular cloud, I'm a type of nebula. I have a high density and a very low temperature. This combination creates a gas, molecular hydrogen. That's primarily what I'm made of, along with cosmic dust within. When the force of gravity exceeds the outward push of gas, the pressure is so great that I can't help it and start to collapse, which is caused from a shockwave from a near exploding star, or when two molecular clouds collide. Now isn't that bizarre? When the gravity's too strong, I break apart into smaller clouds. Each cloud is a star's beginning, in which I am very proud. Protostars are the name of the clouds that do break free. Let me introduce a protostar that was a part of me. Hello there, I'm the beginning of any kind of star. Let me introduce myself to you, I am a protostar. My core is not hot enough for fusion to occur. To achieve that level of stardom, that process is a chore. The first thing I do when I break free from my molecular cloud, I start to spin until I form this disk around me you see now. As the disk rotates, I produce a strong magnetic field, pulling gas and dust into my center core as I reveal. The infalling gas releases a kinetic energy, creating heat, increasing the temperature in the center of me. At this point I can transform into a hydrogen burning star, which is when the nuclear fusion starts in a protostar. This is when I cross over to stage 3 called Titori. We play our different roles in the star formation you see. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a Titori star now, also a pre-main sequence star. My job's to clear away the dust and gas and send it really far. My stellar winds create bipolar outflows that decrease my mass, till I'm a main sequence star, my center burning nuclear gas. Now I'm a main sequence star, now just like the sun you know. For billions of years I will burn throughout my light show. Converting hydrogen to helium is how fusion exists. It wants to blow me apart but has a hard time doing this. Cause of gravity of equal power pushing me in, I'm able to stay burning since the fusion did begin. There are many different kinds of stars throughout the universe. Go learn about them all now that you know how they are birthed. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes.
Classification. Look at all these stars. What do you notice? I notice that the stars have different colors. Some stars appear brighter and some appear very dim. Some look very big and some look very small. They all have different characteristics. Stars are classified by size, magnitude, temperature, and color. Let's look at the size of stars. The largest are called supergiants. Here we see one of the largest supergiants, Betelgeuse. Here is the diameter of the star for Betelgeuse, compared to the size of Earth's orbit. You can also see the size of Earth's orbit right here. That's the diameter. And here's the size of Jupiter's orbit. Jupiter's orbit would be right here, this long. The smallest is called a neutron star. The diameter of a neutron star is about 20 kilometers. That's about 12 miles, which is half the distance from Disneyland to Los Angeles. From size of stars, the smallest are neutron, followed by dwarf, middle-sized, giant, and supergiant. Magnitude of stars. This is also called luminosity, and it describes how bright a star is. Scientists use the absolute magnitude and not the apparent magnitude. The absolute magnitude tells you the true brightness of the star. The apparent magnitude is how bright the star appears to us on Earth. Closer stars appear brighter than farther stars. A flashlight in your face, for example, appears brighter than stadium lights a mile away, even though in reality, the stadium lights are brighter than a flashlight. Let's look at the temperature and color of stars. Color and temperature go together. The color changes in relation to the temperature. So the hottest stars are blue. The coolest stars are red. In order from hottest to coolest, we have blue, white, yellow, orange, and red. Our sun. Our sun is a medium in size, medium in magnitude and brightness, and medium in temperature. It's yellow. Scientists use a tool called the HR diagram to help show the classification of stars. On the HR diagram, scientists plot the star's temperature versus its absolute magnitude. For absolute magnitude, the more negative a number is, the brighter it is. The more positive a number is, the dimmer it is. Notice when plotting the stars on the HR diagram, you can represent their color and also their size. What do you notice about the size of the stars compared to the magnitude? I notice that the larger the star is, the brighter it is, and the smaller it is, the dimmer it is.